Yeah, Abdita, read it. Huh? Parsi.
An unmagnetized iron bar PQ is placed near to the magnet on the laboratory bench. Figure 1.2 shows the two poles of the magnet and PQ. The iron bar is initially at rest and the magnet is moved to the right very slowly. When the magnet is a short distance from the iron bar moves very quickly to the left towards it. Explain why the iron bar is attracted to the magnet.
Explain why the iron bar is attracted to the magnet. Yeah, 3 marks there. 3 marks showing you that you have to bring the 3 points. Iron bar is attracted to the magnet. So why it's attracted? You have to write in 3 points. Have you got 3 points? Hmm? Adrita,
No.
how many points you got?
Um, one or two.
So what you got? Can you tell me?
Um, I got that the iron bar is a iron is a magnetic substance. It gets attracted to the magnet because um, when it's brought closer to the magnet, the domains are arranged in a fixed direction. Well,
Hmm.
that's it.
That's it. That's it. Okay. So what you said, it gets magnetized, right? If
Yes, sir.
iron bar is brought closer to the magnet, it gets magnetized, isn't it? If
Yes,
something it is getting magnetized, that means it's also behaving like magnet. It's induced magnet, right?
yes, sir.
And if it is induced magnet, then its end P and Q also will have poles, right? So
Yes, sir.
P will turn to north pole and Q will turn to south pole. Is it clear?
Yes, sir.
Okay. Now, as P is north pole and here we have S pole, we are having opposite poles closer to each other, unlike poles attract, right? We know unlike poles they attract each other, right? One of the properties of
Yes,
magnet.
sir.
So here we will arrange these 3 points. First point, what you said, the domains are arranged. Uh, for all this discussion, we can say this is first point, that is the iron bar gets magnetized, right?
Yes, sir.
So you write it here. First point is the iron bar gets magnetized, or you can say turns to iron bar turns to induced magnet. Same idea, right? Or whatever you said, the domains are aligned, right?
Yes, sir.
In a direction, in a particular direction. So induced magnet. Then second point, He turns to north and Q turns to south pole. Third point, unlike poles get attracted. Got it? Hello?
Yes, sir.
Any questions here, anyone? Have you understood, everyone? Hello? Maimuna?
Yes, I understood.
Yes, sir.
Farabi?
Yes, sir.
Are you writing?
Yes, sir.
Thank you. Please write. This one again you'll write in your worksheet after getting it printed. Yeah, Farabi, read.
The flexible iron strips WX and YZ are placed close to each other inside a solenoid long coil. The end W of WX and the end Z of YZ are held firmly in position. Figure 2.1 shows that the solenoid is connected to a DC power supply and a switch. The switch is closed and there is an electrical current in the solenoid and W of flexible iron strip WX become a magnetic S pole. State the type of magnetic pole produced at X, Y, and Z.
Okay. So here W is becomes south pole, right? Isn't it? The left side becomes south pole. Then what will happen to X if W is S pole, south pole? Then X will be which pole?
North
Farabi?
Pole.
North pole. North pole. Very good. Very good. Then if X is North pole, then what will happen to Y? Hello,
It will become the South Pole.
South pole. Because it's also getting the current in the same direction like the way W is getting, right? So
Yes, sir.
YZ, for them also we will get the left side South pole and the right side North pole. Is it clear, everyone?
Yes, sir.
Okay, so here X will be X will be N pole, then Y will be
South.
S, then Z will be North, right? Any questions here, anyone?
No, sir.
No, sir.
Lamisa and Mariam is not here. Where is Mariam? Maimuna?
Sir, she sent a text in the group. She's not feeling well.
Oh, this one is done. Now, next part. Yeah, continue. Farabi, continue this.
State and explain what happens to X and Y because the flexible iron strips are magnetized.
Yeah, what will happen to X and Y? For X, you got which pole? Farabi?
North.
Farabi? Hello? Farabi? Farabi, are you listening? So, Mahi, you tell me for X what you got? Mahi, hello?
Sir,
For X, what you got? North Pole, right?
yes, sir, North Pole.
And for Y, what you got?
South Pole, sir.
South Pole. Then what will happen to them?
Um, sir, they will attract
They will attract each other. Why they will attract each other?
because they are unlike poles.
Yes, unlike poles attract. Got it?
Yes, sir.
Okay. The same idea we got, right?
Yes, sir.
Okay. So we are done, right? We are done with this question. And next we have part B. Maimuna, you read?
So number 3,
No, B. B is left. Two
a
B is
relay
left.
operates a switch in one circuit using the current in a different circuit. State one example of a relay used in this way and explain why a relay is used.
Okay, so we are using relay circuit. We know what is called relay circuit, but why why we are using relay circuit, this idea you did not get, right?
Yes, sir.
Why we are using relay circuit? To avoid an unexpected situations. Like one example we are giving you in nuclear power station. In nuclear power station, there is risk of radioactive emissions, right? Isn't it? Hello.
Sir.
So to control the nuclear power station, we use relay circuit so that we can we can avoid radioactive hazards. Is it clear?
Yes, sir.
Okay, so you write here example first. First you write, I will give you, though they wanted one example, but I will give you here two examples for your learning. Okay, so number one, nuclear power plant. In nuclear power plant, we use relay. Why we are using relay circuit? To avoid radioactive hazards. Number two, you know car, right? Car, when we are starting car, we are using a small key, right? Small circuit is over there, and that circuit is turning on the bigger engine circuit where we have sparking to run the engine, combustion chamber of the engine, right? So if you want to do it directly in the combustion engine, then there is a risk, right? Hello, hello,
Yes,
are you
sir.
listening? So the risk is the one risk, there is high voltage over there, the combustion engine where the circuit is working, that there we have high voltage. This is one risk, and another risk is there is very very large amount of thermal energy produced. Okay, if you go closer to it, then it will be a problem. There might be problem for you, right? Isn't it?
Yes, sir.
So starting motor of a circuit, you write here, starting motor of a car. We can avoid high voltage or or greater thermal energy during sparking. Okay, have you understood now the relay circuit wire we are using?
Yes, sir.
And also we got one example in the MCQ part where you got one example of relay circuit that is for intruder alarms. Okay, that's for intruder alarms. How the intruder alarms work, you will know it later. Okay, when we'll get the applications of LDR, light dependent resistor, or LED, light emitting diode, that time you'll get the idea. Is it clear? Hello.
Yes, sir.
We are done with question 2. 24, 24, 5, yeah, 6. Are you feeling tired? Hello, Adrita,
Yes, sir?
are you feeling tired?
No.
Mahi, Maimuna, is it all right?
Yes, sir. Uh,
Yes, sir.
Maimuna is only talking. Adrita and Mahi is silent. That's why I'm asking that. Are you tired? Okay, Adrita, you read 3.
A vertical solenoid, a long coil with an iron core, is held in a wooden clamp above a laboratory bench. The solenoid is connected in series with a battery, a switch S, and. Sir, what's this?
A switch S. Here is switch S.
No, no, after that.
An emitter.
What does
And
that do?
oh, you don't know. Emitter is a device which is measuring current.
Oh, an emitter and a variable resistor. There's a voltmeter in parallel with the solenoid. So, what's the
Okay, okay.
voltmeter?
Let me clarify some of the things. Here, variable resistor is a resistor. Resistor means which one is opposing the current. That means if you have more resistance, then there will be low current. So variable resistor means the resistance which we can vary. Like we can make it 5 ohm, or we can make it 10 ohm, we can make 20 ohms. According to our need, we can change it. That's why it's called variable resistor. Okay. Then we have voltmeter. Voltmeter is a device which is measuring the voltage. Okay, between the 2 points in a circuit, it can measure the voltage. Is it clear?
Yes, sir.
Hello. Okay, then continue.
Figure 3.1 shows the apparatus. Number 1. The current in the solenoid magnetizes the iron core so that the lower end of the core is an end pole. On figure 3.1, draw the pattern and indicate the direction of magnetic field in the region surrounding the iron core.
So this one, you know how to do it, right? They
Yes, sir.
already said you where is North Pole, so you can understand where will be South Pole, right? Isn't
Yes,
it?
sir.
So if here they gave lower end is North Pole, so we write here N, and then this side will be South Pole, right? Then you know how to draw the field lines, right?
Yes, sir.
And here is, you see, they gave you 3 marks, so it's important to know uh, how you will get these 3 marks. Then you see how I'm drawing. You also draw like this in your worksheet when you will get it printed. So you must have to give field lines in both sides. Okay. So you label here north and south. Then you give here field lines both the sides. 2 2 minimum 2 2 you give, huh? Your drawing will be surely better than me, right? Huh?
Yes, sir.
Inshallah. You see here it's very tough to draw on the screen. So you should draw in a way following the field lines rules. We gave here 3 rules. One of the rule is magnetic field lines never cross over, right? So we should follow that, that they are not crossing each other. And third mark is for showing the direction of the field lines this way. Okay. So this way we will give your field lines direction and draw field lines this way. You give your north and south pole. Got it? How to draw? Hello?
Yes, sir.
Yeah, I'm sending it in your group. Already you got here field lines, how to draw here. On 15th, we gave you the field lines direction. You try to draw like that. This is 7th image for today. You are also drawing, right?
Yes, sir.
Hello? On your copy, you at least draw, then there will be practice for you. Yes. Yeah. Now next. Yeah, continue, Maimuna. Maimuna. Hello, Maimuna.
Oh, yes, sir. My net is really bad. Can you hear?
No problem, no problem. You continue now from here. From here. The student holds. Hello, Mahe.
Yes, sir.
And I,
Yeah, Mahi, you
sir,
read.
can you hear?
Yeah, problem. There is, distortion. Okay. You see,
Yes,
yeah,
sir.
here, yeah. So Mahi, you read. Mahi, please read.
Okay, sir. The student holds an iron cylinder against the bottom surface of the iron core in the solenoid. When he releases the iron cylinder, it stays in contact with the iron core. Explain why the iron cylinder does not fall.
Okay, so bottom of the surface of the iron core. Here you got the iron core in the solenoid. This one is iron core. So bottom part of this iron core, it was North Pole, right? Isn't it? So
Yes,
closer to this North Pole, they are bringing one iron cylinder. Then what will happen? What will happen? We gave you this answer before, right? It will be
Yes, sir.
exactly the same answer of the first question you got. Here, 3 points. You got here 3 points for the first question. Those 3 points you should write here. So what are those 3 points? Can you recall? Hello, Adrita.
Um, yes, sir. The
What are those
cylinder
three
gets
points you got?
magnetized,
Mm-hmm.
or it turns into an induced magnet. And
Mm-hmm.
then
Upper
one
side,
turns into
upper side of the iron cylinder turns to South Pole, right?
yes, sir.
This is second point. And third point is unlike poles attract.
Yes, sir.
So you write here first point, the iron cylinder gets magnetized, right? Then second point, the upper side of iron cylinder turns to South Pole, right? Then third point, unlike poles get attracted. Got it, Mahe? Maimuna?
Yes, sir.
yes, sir.
Same idea we are using here in this question, the one we got for question 1, right? Yeah, this is image 8 for today. Done this part.
Yes, sir.
Then continue. Continue. Yeah, Mahi, continue.
Okay, sir. Uh, the switch S is open. State and explain whether the iron cylinder remains in contact with the iron core.
So if the switch S is opened, what will happen to the iron core? Iron core will lose its magnetism, right? Isn't
Yes,
it?
sir.
Because iron is a soft magnetic material, and when we are stopping the current, switch is open, then we are stopping the current, then it's losing its magnetism, right? The
Yes,
condition
sir.
is removed, so it is temporary magnet. And if this one is losing its magnetism, iron cylinder also loses its magnetism, right? Isn't it? That's why it will drop, right? Iron cylinder will drop down, right? Isn't it? Hello.
Yes,
So
sir.
what should be your answer?
Yes, sir.
The iron cylinder will not remain in contact with iron core as it loses its magnetism, right? Is it clear?
Yes, sir.
So
Yes, sir.
that's all for today. You have one homework, that is question number 4 to solve, right? And you have one task, that is you have to send me the notes in PDF format, right? Notes on topic
Yes, sir.
17. That's all for
Okay.
today, okay? Allah Hafiz.
Allah, sir.
Assalamu alaikum.